Cars today are stuffed with safety technology, and among the most important pieces are the headlights. Whether you're cruising the highways or navigating through foggy backroads, the right headlights can make all the difference. With so many different types on the market, it can be tricky to know which ones are the best for your ride. From classic halogens to futuristic lasers, we're covering it all. So, if you're ready to illuminate your ride with the best options out there, stick around. Let's get those headlights shining. Believe it or not, the first car headlights were actually oil lamps. In the late 19th century, automobiles were equipped with oil-fueled lamps that provided minimal light. These lamps were essentially the same as those used in homes and on carriages. Carbide headlights. Carbide headlights were an early form of automotive lighting, used primarily in the late 19th and early 20th centuries. These headlights relied on acetylene gas produced from calcium carbide and water to create light. Carbide lamps consist of two parts: carbide chamber, which is placed in the lower section, and water reservoir is placed in the upper section. Carbide chamber contains calcium carbide. When water from the reservoir drips onto the calcium carbide in the carbide chamber, a chemical reaction occurs, which produces acetylene gas and calcium hydroxide. The acetylene gas travels through a pipe to the end of the lamp, where it is burned to emit a bright, steady light, which is used to illuminate the road ahead. Acetylene produces a bright, white light that was significantly better than the oil lamps used before. This technology was straightforward and easy to produce using available materials. The main disadvantage of this technology is that frequent refilling of water and calcium carbide is necessary, along with cleaning the burners and other components. The light produced had a limited range and was less focused compared to modern headlights. Drivers had to manually light the burners, which could be inconvenient and time-consuming. Electric headlights. In 1898, the first electric headlights were introduced by the Columbia Electric Car Company. These early electric headlights were a game-changer, providing more consistent and reliable lighting compared to their predecessors. By 1912, Cadillac became the first manufacturer to integrate an electric lighting system as standard equipment in their vehicles. This move marked the beginning of a new era in automotive lighting. Halogen headlights. Halogen headlights are one of the most common types of headlights used in vehicles. They produce a warm, yellowish light that many drivers find comfortable. Halogen headlights were invented in the early 1960s. Halogen headlights were first installed in the 1962 model of the European luxury car, the Citroën DS. The headlights are an evolution of the standard incandescent lights and are known for their efficiency and bright output. Halogen headlight works by taking advantage of a thin tungsten filament mixed with inert halogen gas contained in a piece of glass that is highly resistant to heat. When the headlight is turned on, an electric current passes through the tungsten filament and heats it up to about 2,500 to 3,000 degrees Celsius. The heated filament glows, producing light. The halogen gas plays a crucial role in the operation. It reacts with the tungsten atoms that evaporate from the filament due to the heat. The result is a bright, efficient light. Halogen headlights are relatively simple and cost-effective compared to newer technologies like LED and HID lights. Due to their long-standing use, halogen bulbs are widely available and easy to replace. The main drawback of halogen headlights is that they are not as energy efficient as LED or HID headlights, meaning they can drain your battery more quickly. They may not perform as well in terms of light output and longevity compared to more advanced lighting technologies. HID headlights. Next, let's talk about HID, or high-intensity discharge headlights. These headlights use xenon gas to produce a much brighter and whiter light compared to halogen bulbs. HID headlights began to see use in automotive applications in the early 1990s. The first vehicle to use HID headlights was the 1991 BMW 7 Series E32, which marked the introduction of this advanced lighting technology in the automotive market. When the headlight is turned on, the ballast generates a high voltage to create an electric arc between the two electrodes. The electric arc excites the xenon gas and other metal salts within the bulb, producing a bright, intense light. HID headlights are known for their superior brightness and efficiency. They provide better visibility, especially in low-light conditions, and they're more energy efficient than halogen bulbs. However, HID headlights aren't perfect. They can be more expensive to replace, and their intense brightness can cause glare for oncoming drivers if not properly aligned. Additionally, HID headlights have a warm-up period, meaning they don't reach full brightness instantly. LED headlights. Moving on, we have LED headlights. These headlights represent a modern and highly efficient automotive lighting technology. They are increasingly popular due to their energy efficiency, longevity, and design flexibility. LED headlights were invented in the early 2000s and began to be used in automotive applications shortly thereafter. LED headlights produce light through a process called electroluminescence. It contains a semiconductor diode that emits light when an electric current passes through it. LEDs use a semiconductor to produce light, which makes them incredibly efficient. They use less power, generate less heat, and can last upwards of 30,000 to 50,000 hours or more. LED headlights can be easily dimmed or brightened, and they can also be rapidly switched on and off. This flexibility allows for advanced lighting features, such as adaptive headlights and daytime running lights. LEDs are compact and can be arranged in various configurations, allowing for more innovative headlight designs. This flexibility is particularly useful for automotive manufacturers designing modern, stylish vehicles. LED headlights can produce a very bright and focused beam of light, enhancing visibility on the road. They often provide better illumination than both xenon and halogen headlights, especially in terms of color temperature and light distribution. These headlights can throw light up to 300 meters. But, like all headlights, LEDs have their own set of drawbacks. They can be more expensive to produce and purchase up front compared to halogen or HID lights. LED headlights often require complex electronic control systems to regulate voltage and current. This complexity can make repairs more challenging and expensive if issues arise. LEDs are sensitive to heat, and excessive heat can affect their performance and lifespan. Proper heat management, such as heat sinks and cooling systems, is necessary to maintain optimal operation. LED headlights, especially improperly installed or poorly aimed ones, can produce glare for other drivers. This can be a safety concern, particularly if the headlights are not correctly aligned. Laser headlights. Now, let's talk about the cutting-edge technology of laser headlights. These are still relatively new to the market, but offer some impressive benefits. These headlights utilize laser diodes to produce extremely bright and focused beams of light. Laser headlights were first introduced and demonstrated in concept vehicles and prototypes in the early 2010s. The first car to feature laser headlights was the BMW i8, introduced in 2014. The BMW i8 was a plug-in hybrid sports car that showcased innovative technology, including its laser headlights. Laser headlights are currently found in high-end luxury vehicles and concept cars due to their advanced technology and premium features. Laser headlights are highly efficient in terms of energy consumption. They require less power than traditional lighting technologies like halogen, xenon, or even LEDs, while producing a brighter and more focused beam of light. One of the major benefits of the laser headlights is that they are significantly brighter than other types of headlights, including LEDs, providing enhanced visibility at night and in adverse weather conditions. Laser diodes have a long operational life, similar to LEDs, and can last for tens of thousands of hours under normal usage conditions. Laser headlights produce a pure white light that closely resembles natural daylight. This improves visibility and reduces eye strain for drivers, enhancing safety during nighttime driving. The main drawback of the laser headlights is that they are currently more expensive than LED headlights, primarily due to the cost of laser diode technology and associated components. The technology behind laser headlights is also complex, requiring sophisticated optical systems and precise engineering. Some regions have regulations regarding the use of laser headlights due to concerns about glare and safety for other drivers. Meeting these regulations can be complex and may vary by region or country. Laser diodes generate significant heat. Therefore, these headlights require robust cooling systems to maintain optimal performance and longevity. As of now, laser headlights are primarily found in high-end vehicles due to their cost and technological complexity. They may not yet be widely available or affordable for all vehicle segments. Adaptive headlights. Adaptive headlights are an advanced automotive lighting technology designed to improve visibility and safety by dynamically adjusting the direction and intensity of the headlights based on driving conditions, vehicle speed, and steering angle. Adaptive headlights were first developed and introduced in the early 2000s. One of the early adopters of adaptive headlight technology was BMW, which introduced its adaptive headlight system in 2003 on the BMW 7 Series E65. Adaptive headlights are equipped with sensors that detect the speed of the car, steering angle, and other factors. Based on this information, the headlights can swivel in the direction you're turning, automatically dim high beams when oncoming traffic is detected, and adjust the beam pattern for different speeds or weather conditions. This innovative technology marked a significant advancement in automotive safety and driver assistance systems. One of the major advantages of the adaptive headlights is that they contain advanced systems that has ability to independently control multiple light segments to create specific patterns, such as blocking light from shining into the eyes of other drivers while maximizing visibility elsewhere. By automatically adjusting the beam direction, adaptive headlights help drivers see obstacles and pedestrians sooner, reducing the risk of accidents. These headlights also reduce the need for manual adjustments, allowing drivers to focus more on the road. However, adaptive headlights also have some drawbacks. One of the major drawbacks is that vehicles equipped with adaptive headlights tend to be more expensive due to the additional sensors, actuators, and control systems required. The technology behind adaptive headlights is sophisticated, which can lead to higher maintenance and repair costs. So there you have it, a comprehensive look at the different types of car headlights and their drawbacks. Whether you prioritize cost, efficiency, brightness, or cutting-edge technology, there's a headlight out there to meet your needs. Just remember to consider the potential drawbacks when making your decision. Thanks for tuning in. If you found this video helpful, don't forget to like, comment, and subscribe for more automotive insights. And let us know in the comments which type of headlight you prefer and why. Until next time, drive safe and keep those headlights shining bright.